Hey folks, and welcome back to another Rottler series here. I'm Ryan from the applications department, and today, stick around, I'm going to give you a walkthrough here. Behind me is our S86A CNC surfacing machine. This is a great machine, fast, easy to use for doing cylinder heads and even blocks in it. Today I've got it equipped with our dual axis leveling table that makes a nice universal fixture that you can level up any head on. And this thing has got 51 inches of travel on the S86 model. We also do an S85, which is 10 inches shorter. The 86 here can do anything from small automotive 4-cylinder V8 type cylinder heads all the way up to very, very large over-the-road inline 6-cylinder heads such as the Cummins ISX. So today I've got a aluminum Duramax head here that is ready to be surfaced. We're going to hop on in here and I'll give you guys a walkthrough. We're going to be using our PCD insert because this is aluminum. This machine's equipped with a 16-inch fly cutter. We'll go ahead and deck this thing and show you how it's done. Okay, so we're over here at the machine, and what we got here is on top of our leveling table is we've got a series of, they're not really locators, the back kind of is, but they're kind of a parallel locator combined. And what we want to do is our cylinder head is going to rest on these 4 points, and our front left one here is an adjustable jack screw. So we want to get this thing sitting on 3 points and then bring that up just to stabilize. Now the trick here with this clamping system to make it so fast is this is a quick acting single clamp screw, and this is at a little bit of a downward angle, so when the cylinder head is clamped and gets registered against these adjustable backstops, we want to make sure these are shaped as kind of a dovetail. We want to get this hooked in either to a lip on the outside of the cylinder head, or ideally we typically will put this inside of the ports. So I'm going to want to hook this down with the head laying in there, just right here on the dovetail angle inside the port. Now, if you look online or in the manual for our 7209M leveling table, the manual comes with a bunch of pictures and images of how to set these up for various cylinder head models. Often what I'll do if I'm just doing a single head or just need to do a quick setup is the way I do it is I just leave everything loose on the table, and then I can kind of slide everything and get it into place, and then I'll lock everything down. So we'll go ahead and do that now. I'm going to get my clamp out of my way. And like I say, what I want to do is I want to take my cylinder head here and get it resting, so it's going to be resting on the valve cover side. And I can slide these blocks and just get them about midway on these ports. Get myself in a nice supported position. And the other thing I want to check is I've got 5 T-slots on this table, and I want to make sure that my head's close to center of the spindle. This machine, it's a CNC controlled machine for the horizontal and vertical axis, or X and Z. We don't have a Y. We are able to float our fixture back and forth. There's a single clamping screw in here. You can get about 2.5 inches of slide back and forth, but it's easiest to just eyeball and make sure wherever you place these risers that it's going to be enough for your cutter to clear evenly on both sides. So once I get this kind of just set in here, and what I like to do is kind of split the difference. I always like to have my front spacers where they're going to be, when the clamp is pushing down, it's going to kind of sandwich the head. That's going to give me the best rigidity and make sure I'm not warping the cylinder head or anything under clamping. So what I can do is once I get all this stuff close, I can take my 3/4 open end wrench and I can just snug down all of these risers. And now I'm going to make sure my little dovetail posts, which are still loose, those are just set with a set screw. So you can take a 7/32 set screw or Allen key to tighten the set screw. And once you got those at the height that you want them to be, just go ahead and tighten those up. Okay, so this gives me basically my base location for this, right? And now when I take this, so I'm doing two heads of the same, I can load this in here, push it up so it's hooked in both of those ports, right? And this is going to be my location for this this Duramax head or any other Duramax heads that I'd be doing in the same day. I want to make sure that I'm just touching here, so I'll just run my finger across my jack screw pad here, just so I've got pressure and I'm touching on 4 points. And now I want to set up my clamp. So again, start with the clamp loose, and we're just looking for anything that will allow us to hook in here. Now there's plenty of relief positions on this casting, and so if I stick this right about in here, just get this location hand tight for now, grab an adjustable wrench, and we'll tighten down the nut. So that gets the base of my clamp in position. And the way this works is this is slotted to allow these threads are relieved to be kind of a square. And what I can do is I can slide this up until it's just touching. And when I turn it, there's a threaded collar that's going to apply clamping pressure to the cylinder head. Now, it's very important to have those dovetails engaged because, like I say, what happens is this pushes down and it'll scoop the back out. You don't need much. A little bit of tension on there, and then you want to come back and check your jack pad right here and just make sure that everything's secure. So once we have our cylinder head secured in our fixture, we're going to go ahead and write a program. We're going to level this up. And today, there's two options for doing this. Today, we're going to use the dual axis level that we have. We can just simply set this on here. This method is fast, it's easy, and it works accurately as long as you have a leveled machine. This one's been recently leveled, so we're okay. Good way to check is, if you're running in a shop, you can stick this down here and double check periodically that your machine is level. If we're going to be leveling heads, then we want to make sure that the machine matches. Your other option is to sweep your cylinder head surface in. You can do that by putting a mag base on the fly cutter. That'll allow you to sweep front to back and left to right. Now the way this table works here is we've got forward and back and left to right adjustment in this. And we have a lock over here on the left. So if I unlock my cam, now I'm going to have control. My left one's going to do my front forward and back. So I just want to get this centered up in this machinist level. And my right's going to do my left to right adjustment. So I'm a little bit out, a little high on my left here, so I'll just pull it back in. Okay. We'll give that a lock. So now I've got a leveled cylinder head. It's secured. And one thing is you always want to clamp this cylinder head before you level. When you go to level, if you apply torque to this thing, it can bow. You might not have your jack pad screwed up, so things can shift. And if you level before this clamp is in its final position, then you're not going to have an accurate level after you tighten everything down. So you always want to tighten first, then come and do your level, lock down your table. So over here in my software, I have the ability to write a new profile. And this software, what it does, it's multiple programmable depth of cut, and it has parameters, boxes that you're going to fill out that for your roughing and your finish parameters. So an example would be, say we want to take 10 thousandths off of a head. Well, we might want to do a roughing pass, or maybe two roughing passes at maybe 5 or 8 thousandths of material being removed, just to remove the bulk of the material, and then come back and finish just with a 2 or a 1 thou pass. We can program those settings, and we can run different RPM and different feed rates in both our rough and our finish settings. Now, we also have to go and store, just like any CNC machine, we need to give this a start location and an end location. And this dial indicator that's on the left side of the shroud of the spindle, this is set up to reference, it will read 0 when it's in the down position. You hold it down, this will read 0 in its reference to the cutter tip. So if this says 0, then that means that you're at the height that the insert would just be touching the surface. So what I can do here is I'm going to jog down with our touch screen. And I just want to make sure that I'm over my cylinder head here, find a good spot to touch this thing. Okay. And I'm going to come down. Now, this machine here we have here, I've got it equipped with our optional remote hand wheel. And what this lets me do is I can tap my hand wheel increment identifier over here, and then I can use the hand wheel for fine movements. So what I will usually do is I'm going to use this little touchscreen slider till I'm just touching, and I always set my dial indicator to where it's got to go 1 wrap around to 0. And so what I do here is I hold this down in position. I can select the 10 thousandths increment with my hand wheel. Now I'm just going to give this clicks until I'm close to 0. I'll move over to the 1 thousandths increment. And I just want to make sure that I'm seeing 0 with 1 wraparound on my gauge. At this point, I'm going to save this location under here on my program position for horizontal and vertical zeros. That's going to give my start location for the machine to move to, where it's going to turn spindle on and take a pass. And I can move the machine back up. And what I want to do is I want to find my end location. So I just come over. And I've got my insert already loaded in my cutter here. What I'm looking for is I just want to make sure that my insert's going to clear both the front and the back edges of this. So I don't have to go all the way across or off the end of the part. We do have about 1/1000 to 2/1000 of lead at a 14-inch swing radius on these machines to make sure they won't back cut. So I just need to make sure that I'm going to clear my cutter on both sides. So you just eyeball over into position. The closer you get it, the less time wasted. We're just about a 1/2 inch to 3/4 pass. And what I can do is I've got an option for cut length and cut depth. So this is going to be my cut length. So I'll just hit the set button here by horizontal. And it just entered in 23.422. So that's 23.4 inches from where we set our 0. And I'll just jog the machine back over here manually. Get it close to my start. Now, I want to go and program in some parameters for feeds and speeds. So on my left side, I've got roughing parameters, and on my right here, I've got finish parameters. So for a roughing feed rate on aluminum, we can do something like a 20,000th inch per revolution feed rate. For the depth here, let's say that, imagine we want to take 5/1000ths off of this. So let's say for our roughing pass, we'll take 3/1000ths of material. And the RPM, this is a 16-inch diameter ply cutter running in aluminum. I'd usually run this at about 800 RPM. You can go up to 1,000, somewhere between 800 and 1,000. So we'll go ahead and type in 900 today. And on my finish parameters here, now my finish parameters, the feed rate for my finish is going to dictate what my surface finish is actually going to be. That's the main driver. So aluminum MLS gaskets, you want something, usually at least a 20 micro-inch RA. In that, we're using our 3/8 PCD cutter here. I typically come in and run, for starters, try something like a 0.008 thousandths inch per revolution. See how it goes. If you have a profilometer, you go ahead and check it. And then for the depth, I always like to, on my finish, my minimum material, I always like to take 2 thousandths. 2 thousandths is enough to actually create a chip, so your insert, get good tool life out of your insert, and you'll usually reduce some of those track marks that you would get if you're taking a very, very light cut. And it's just usually a slightly better finish, and like I say, a little bit longer tool life. So 2 thousandths for the finish. On my RPM, usually because on a finish pass, we're running at a much slower feed rate, right? So it's going to take longer. Two things. I like to kick my RPM up because the overall inch per minute becomes a little faster then, so it saves a little bit of time. But it'll also give me an audible kind of reminder if I'm working around in the shop and I hear the spindle increase in speed and I go, oh, okay, that's on its finishing pass now. It gives me just a nice friendly reminder, basically to say, oh yeah, pay attention, this thing's probably going to be done. You might have to come over, unload and reload. Makes it a little efficient for me. And the last thing I want to do is I just want to tell it the depth of cut, the total amount of material I'm going to remove. So in my mind, we've been kind of talking about doing 5 thousandths, so I'm going to type in 5 thousandths. Now what this will do is, because I gave it a 2 thousandths depth for the finish and I gave it 3 for the roughing pass, the way this works is it looks at my total depth, which right now is 5 thousandths. It subtracts that finish amount, basically saves it for later. So if it's got 5, it's going to take 2 off of that. And then it'll do as many roughing passes as it can until it's left that 2. So this gives you a level of automation. You know, if I had to take 10, what it would do is it would say, well, I got to leave 2 on there, so I've got 8 to play with. Okay, so take 3 thousandths wax, as many as you can, and leave 2 on there for my final pass. So it makes it automated, switching from roughing to finishing. So I'm going to go ahead and just hit the save button up here, but that's it. That's programmed my my entire operation, my program. This is saved for later. And what I can do now is on the cycle start, if I come down here, this moves into its start position and my cycle start button has now gone yellow. This is a pause point to allow me to check that everything looks right. And I can bring my dial indicator, and right now it's reading 3 thousandths past 0. So on my DRO over here, it says my vertical position is 3 thousandths. My indicator says I'm at 3. Now, one of the most unique and the coolest things about this machine is that if I was doing a batch of these Duramax heads, and they're going to have different thicknesses, you know, maybe a couple thousandths, maybe more. What I can do is I can load my head, and from this point right here, I have full control over this machine. As long as I don't press cycle start, I can reset anything I want. So if you could imagine that I had just loaded this cylinder head, and I came down into my 0 position, and let's say that this said there was 5 thousandths being taken. Well, I'd want to adjust, and I can re-click this up until I'm back at 0. And that would let me re-zero my program, and then I can hit go again. So this allows you to do some production in here without having to change things. So I'll double check. We're back down at 3. We're ready to cut. So we're going to spray a little bit of blue on this. We'll bring the camera in just to get the nice action shot, and we'll let this thing cut. All right, so that's wrapped up. I've got my SJ210 Mitutoyo. This is a skidded style profilometer. These handhelds are pretty good, but we're just going to give this a quick trace. See our surface finish here. So I'll set this and get it aligned with the lay pattern here. And let's take a quick trace. So what these profilometers, as they're called, for those of you who may not be familiar with them, is these use a small, very tiny cantilever balanced diamond tip, and it can measure the deflection as it drags across the surface. So with our fly cutter, we're making an arc with that insert, and you've got what's called little scallops. And as the insert comes around and removes a chip, that's what creates your surface finish. So this device, by dragging across that and going over those peaks and valleys, that's going to measure those deviations, and it'll give us a number, the common one being RA, which is a roughness average in micro inches. So if we take a look here, we've got a 13.04 micro inch RA here, and plenty good, exceptionally good surface finish. Would work with just about any MLS gasket. Like I say, usually you want to get 20 or slightly below with most MLS gaskets anymore. So that's it. This is, again, it's been the S86A CNC surfacing machine. Dual axis 7209M dual axis leveling table. If you guys are interested, have any questions, go ahead and give us a shout. You can reach me. My email is ryan@rottlermfg.com. And if you're in the market, need some help with surfacing, go ahead and go to our website, rottlermfg.com. Check out the S80 series surfacer machines. And as always, take care and happy machining.